All right, so this section is called the area problem. It has two major topics in it. One is brings back summation, and one is like finding the area under a curve, which again is like one of the first things that you'll go over in calc. So this chapter is basically chapter 1 in calculus. So hopefully, fast forward to April, till August, you have a little bit of an understanding of it. So these are your summation rules, okay? These are ways to take summation and do them without having to plug in each individual number. So if you remember summation, we did this in chapter 8. But if it said this and then it said a number 10 at the top, and let's just say it said 2i here, then one way to do this is to plug in 1 and plug in 2 and plug in 3 and plug in 4 and plug in 5 and plug in 6 and plug in 7. I should have picked a smaller number. 8, 9, 10 and added them all together, right? Like that's the foundation of summation, is that find each individual value and then plug them in. Obviously, the more complex that gets, or the bigger the number at the top is, the longer that process is. We learned about arithmetic sequences and how to find that sum, and we learned about geometric sequences and how to find those sums, okay? So these are, if you were in Algebra 2 Honors, we actually talked about these last year. These are almost shortcuts. They are a way of rewriting summation. So the first one just says the summation of something that just has a constant. So if next to your little sigma, which is the Greek letter that's your Greek letter, if what's there is just a single constant, then all you have to do is multiply the number at the top times that constant. So if I had sigma and it said I equals 1 and the top said 10 and this said 2, then all I have to do is 2 times 10. So just a constant, you just multiply it times the number at the top. When we did these last round, we worried about what would happen if the bottom number was not 1. You remember the top is where you stop and the bottom is where you start. So if the bottom number was like 0, then I would have actually multiplied by 11. The good news is in this stuff, they all start at 1. So the bottom all starts at 1.
If it was 10, wouldn't it be like 1 plus 2 plus 3 plus 4 plus 5?
No, because there's nothing to plug in here. Every term is 2. So for n being 1, it's 2. N being 2, it's 2. N being 3, it's 2, 2, 2. There's no variable there to plug in. The next one has a variable. So if you have a variable just by itself next to it, so let's just say that said exactly what that looks like, but there was a 10 at the top. 10, I equals 1, and this is I. Then this is how we do it. We do n times n plus 1 over 2. So I would, in this case, my n is 10. So this would be 10 times 10 plus 1 all over 2, or 5 times 11, which is 55. Which is obviously way faster than plugging in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then adding them all together. This thing I will give you for your quiz. So you will have this box, okay? I don't know that she gives it next year, but that's next year's problem. You'll get this for the quiz. This white box you will get with 1 through 6. Yep. All right, the next one is if the I is squared. So if your variable is squared, then we do n times n plus 1 times 2n plus 1 divided by 6. So if we just keep using the same example, if it was I equals 1 on the bottom, 10 on the top, and this said I squared, then I would do 10 times 10 plus 1 times 2 times 10 plus 1 over 6.
So what if it goes, so it goes like 20 or just...
So then the ends would be 20. 20 times 20 plus 1 times 2 times 20 plus 1 all over 6. Okay? If that variable is cubed, I use this formula. So again, if this was a 10, then this would be 10 squared times 10 plus 1 squared over 4. I think I put 2 summation questions on there. There's 10 total, so 20 points. Yeah. Then you've got a sum. So a sum, like if you've got something plus something inside these parentheses, or a difference, because it could be a minus, you can actually break these apart, and it would be the sum of the first thing plus the sum of the second thing. If it was a minus in between, it'd be the sum of the first thing minus the sum of the second thing. So if I had something, again, we'll put 10 at top, and this is I equals 1, and let's say that this said 2i plus 3. Good morning. So I can break, actually, let me just make it I plus 3 for now. I could break this apart. So I can make this the sum of I plus the sum of 3. And then I can use the rules of I from number 2 up here to replace that one. N times n plus 1 over 2 plus 3 times n if it was a constant. So you can break them apart and then use the individual rules. And then the last one is if there is a scalar multiple on it. If there's a number being multiplied by the term that has the variable, you can actually put that number on the front of your summation, perform whatever the summation is, and then multiply it times the number at the front. So that would be something that looks like this, 10i equals 1, and say 2i was here. I would move the 2 to the front, so 2 times the summation of I. And I would go back to my I rules, which again at the top say n times n plus 1 over 2. So this would be 2 times n plus 1 over 2. And then I would plug in 10 and I would simplify it. So there could be like 7 terms if you, well, it would be not higher than the cubed, but it could say like I cubed plus 2i squared minus 3i plus 10, and you could break that down into 4 different summations and then perform them each individually and add them together at the end.
Wait, if it was, let's say if it was like 10 and then it was I squared, that would mean you do to 100?
No, for I squared, we would use this formula and you would plug 10 into each of the ends.
But what would it mean if it was I squared? Like if
You mean if you were just doing them individually?
Yeah.
You would plug in 1 and it would be 1 squared, 2, 2 squared, 3, 3 squared, 4, 4 squared, 5, and then add them all together at the end.
So it would be 1 squared plus 2 squared plus 3 squared?
Correct. Yep. All right, so if you want to screenshot that little box, you're going to use it a lot. I should have done it before. All right, so example 1, again, it says evaluate the sum using the summation formulas and properties. And I can't, PowerPoint is just not working with me. So the same thing with Word. These should be on top of these, okay? But they are next to them. It means the same thing. So it would be 20 with your sigma I equals 1 of I squared. So we just said, and I'll pull it in so we've got it in front of us. We just said I would break it down first. If it was a sum or difference, I would break it down into its parts. This one is not. It just has that one term. So I go to my I squared formula, and my I squared formula is n times n plus 1 times 2n plus 1 all over 6. And then the bottom is 1, and it will remain that way. Like I said before, it's not going to try to trick you. In other sections, we started at 0 and stuff like that. That would be different. You would do top minus bottom plus 1 is the way you would find it. But these all start at 1, so we can just use the top 20 as our n. So 20 times 20 plus 1 times 2 times 20 plus 1 all over 6. And then I'm going to give you can use a scientific calculator. You're actually going to take this quiz on Canvas, and I'll give you the scientific calculator on the lockdown browser if you don't have a scientific calculator. Okay, but you can't use a graphing because there has a summation. And you can't use the ones like the TIs that have the summation. But you can use either for a function and if you want me to check to see if it has a summation, I think that one's fine. You can't use the ones that have the summation because literally we could just type that in, which I'll show you how to do to check your answers. But I'll show you. Okay, so I'm going to write, maybe just simplify this just because it's easy to simplify it and make it 20 times 21. This would be 40 plus 1, so 41 all over 6. And then just type it in, 20 times 21 times 41 divided by 6, and you get 2,870. You could also just type this whole thing in and not simplify any of it. It will still give you the same answer. All right, go to B. Now, again, if it was a sum or a difference, which we'll get to in a second, we would separate it out. There's not a sum or difference. It's only one term, but there's a scalar multiple on it, right? So we're going to take the 2, we're going to bump it to the front. So this becomes 2 times the summation, 31, I equals 1 of I. And if you go back to your formulas, I by itself would just be a variable by itself. That's your n times n plus 1 all over 2. What's n this time? 31. So this is 31 times 31 plus 1 over 2 or 2 times 31 times 32 over 2. If you want to like simplify it so you don't even have to type it all in, you totally can. Just do 31 times 32. But you can also plug it in its entirety. This way, like I could have done 2 times 31 times 32 and then divided by 2. I still get the same answer. Questions on that one?
Wait, so that one, it has 2I, but that...
The 2 bump to the front. So we take the 2, we push it to the front, then we use the I summation formula, and then we multiply it times 2 at the end. Good? Yeah? All right. Go to example 2. Same set of instructions, evaluate the sum using summation formulas and properties. Okay, look at A. This is the first time we've got a sum or difference, right? So the first thing we're going to do is we're going to break it apart. When you have a sum or difference, you want to break it apart, keep the sign in between it. So I'm going to do the sigma, and you don't have to write it every time. If you just want to do like the E and remember the N at the end, that's fine. But this would be I squared minus sigma 3I. If it was a plus, I'd keep it a plus. If it's a minus, you put the minus. Now, the scalar I want to bring to the front, but I can only bring it to the front of that sigma. So the first one's going to stay as I squared, and the 3 comes to the front of this guy. So minus 3 sigma I. Now, again, I'll bring in our formulas because the I squared, we're going to use the I squared, and we're going to use the I. The I squared is n times n plus 1 times 2n plus 1 over 6 minus 3 times the n, or the I, which is n times n plus 1 over 2. And what's our n this time? 21. So this is 21 times 21 plus 1 times 2 times 21 plus 1 all over 6. Yeah, this is a 21. Thank you. I was like, I didn't write 4, did I? 3 times 21 plus 1 all over 2. And we can type that whole thing in and let the calculator do the work, or you can simplify a little bit. 21 times 22 times, this is 42 plus 1, 43, over 6, minus 3 times 21 times 22 over 2. And again, you can reduce, like you can put your denominators in, you can do whatever you want to do there, or you could simply type it all the way out. 21 times 22 times 43 divided by 6, this is 3,311, minus 3 times 21 times 22 divided by 2, which is 231 times 3, 693. And 3311 minus 693, 2,618. Questions? Good so far? Yeah? Okay. Go to B. See if you can break it apart. See what you get when you break it apart. All right, when you break it apart, you would get sigma of 2I plus 9, and then the 2 bumps to the front. So you have 2 sigma I plus the sigma of 9, and then I itself becomes n times n plus 1, and there's no variable here. So we just multiply that constant by n. So now I've got 2, my n is 32. So 2 times 32 times 32 plus 1 over 2 plus 9 times 32. If I want to simplify it, 2 times 32 times 33 over 2. These are going to cancel. Plus 9 times 32. So it's 32 times 33. 1,056 plus 9 times 32. 288. Good.
I did it.
Good job.
Wait, can you put that picture on the homework?
Did I put it on the homework?
Oh, could you put the picture?
Like on the assignment, you mean?
Yeah.
Sure. Questions on those? Okay, so now I'll show you how to check it with your calculator. So if you have the TI-84, All right, if you have the TI-84, when you go to math, if you click the math button, and you scroll all the way down, I actually usually go top to bottom because it's faster. 0 has summation there. If you click on it, it gives you the little sigma. The A is your variable. So even though they use I, we just use X. So I do X equals 1 in the denominator. I arrow up to the top, not denominator, but bottom. And I do 32. And in the right, I write my equation. 2x plus 9, hit enter. And there's your answer. Okay, which obviously I want you to use to check your answers, but you won't have this to find on your quiz to find those answers. Good?
Yes.
All right, so the second part of this, and we're only gonna do part of it because this gets super complicated, but I'm gonna leave that for Miss Farrier. The area under the curve, you will do a lot in calc. The shape of the curve will change directions, okay? But if I just said like find the area under this curve, at this point we can't find the exact area, right? That is not a shape you can find using your formulas from geometry, right? So what we will do is approximate that area. And then next year, you'll actually learn how to use like summation in here to make it a little bit more accurate. But we're just going to do the approximation part of it. So to approximate the area, you literally draw little rectangles. So if I were to take this curve and I were to make my rectangles as best I can, underneath the curve, you're going to come horizontally and hit a point and then drop it down. And then horizontally hit a point, drop it down. And then you would keep going. And the more curves you make, the more closer to the actual area you will be, because it will be more accurate. Now, because we want to actually be able to find these measurements and them be the same, like your approximations should all be the same, it will tell you how many rectangles to make, or it will draw them for you. So like on the quiz, it would be drawn for you. In the homework, it will be drawn for you. So if you notice, there are how many rectangles in this diagram?
5.
There's 5 rectangles. So we will find the area of each of those 5 rectangles by doing length times width, and then we will add them together at the end. And that will be the approximation of your area. Because there's all this pink space above your curves, this is not going to be an exact area, right? It is actually going to be an underestimate of it because there's space in there that we won't be able to find, okay? So we are going to approximate it. And the way you do it is we are going to, and this is like one of those processes that again is like weird in the beginning, but I promise you it will make a little bit more sense. We are going to take our width here. You're going to have a defined start and a defined end. So if I look here at the start here, what's the x value at that yellow point? 0. What's the x value at the end? 2. So the width here is 2, the total width, right? But how many rectangles are there? 5. So we're going to take that 2 and divide it by 5, and that is each of the widths. Does that make sense? Yeah. So each of these little segments is 2/5. You're going to take your whole, you're going to divide it by the number of rectangles. And that's your width. Now, how do I find the area of a rectangle? Length times width. So I have the width, I need the length, right? How do I find length? The y coordinate at each of these. So I would come up here, because this is where I'm marking 2/5. I would come up here and I would want to know that y. How do I find that?
6.
So it looks like it could be close to 6, but I want a more accurate depiction of it. You're going to plug it into this sucker. So I'm going to plug in 2/5, and I'm going to get that y. Then I'm going to go forward 2/5, so 2/5 plus 2/5 would be 4/5, and then I'm going to plug in that one. And then I'm going to go forward another 2/5, so 6/5, and then I'm going to plug that one in, and then I'm going to go forward 2/5, I'm going to plug that one in, I'm going to go forward 2/5, I'm going to plug that one in. Does that make sense? Okay. So each individual rectangle, and it like I like to separate it out. You don't have to do this, but I literally like separated it into 5. 1, 2, 3, 4, 5. So I knew which one was which, and then I'm going to add them all together at the end. So my first rectangle has a width of 2/5. Well, they all have a width of 2/5, right? They're all 2/5. So if it's length, let me do width times length so I'm consistent. Width times length, width times length. All of these have a width of 2/5. And then the length is what's going to change. The notation for this, so if you ever like watch a video on this, if you ever look in your book or whatever, the notation is f of 2/5 because you're going to take 2/5 and you're going to plug it into your equation. I don't need you to know that notation. You can just simply plug it in, okay? But if that's what we're going to do. So then the next one we said we're going to add 2/5 to it. So I'm going to multiply that times f of 4/5. And then the next one, we're going to add 2/5 to it, and that would be 6/5. And then the next one, there's a pattern here. And then the next one, I'm going to add 2/5 to it, and it should be 8/5. Good. And then the next one would be 2 because it would be 10/5. So it should end at your end. Does that make sense? Okay, now here's the good news. You're going to have a calculator, so you can let the calculator do the work for you on those f ofs. So my equation, which is given to you, is 6 minus x squared. So I'm going to save my 2/5, but I'm going to do 6 minus 2/5 squared, 6 minus 4/5 squared, 6 minus 6/5 squared, 6 minus 8/5 squared, and 6 minus 2 squared. That's the easy one.
Are you able to like turn that into like a sigma function?
That's the eventual goal. So eventually, which we won't do, eventually you can rewrite this as arithmetic sequence where 2/5 is the thing that stays and the other ones are what's changing. So it would be 2/5 I, and then you can make it a sigma where it goes from 1 to 5. But let's next year that. Yeah. All right, so now I'm going to work it out. I'm going to do 6 minus 2/5 squared, and you could separate that out or you could type that in. It's up to you. 6 minus 2/5 squared, and I get 5.84, and then I'm going to multiply that times 2/5. And 2/5 is 0.4. 2.336.
This is gonna be all
One problem.
one problem.
Yeah.
Leave it as decimal?
Leave it as a decimal because we're going to approximate it. Yep. And then 6 minus, this would be 16/25, but I can also just go 6 minus 4/5 squared, which is 5.36, and I'm going to multiply that times my 0.4, which is 2/5. 2.144. Then I go 6 minus 36/25, or 6 minus 6/5 squared. And I get 4.56, and I'm going to multiply that times the 0.4. 1.824. And then I'm going to get 6 minus 64/25, or 6 minus 8/5 squared. 3.44, and I'm going to multiply that times 0.4. 1.376. And then my last one, 6 minus 4, which is 2, times 0.4, which is 0.8. And then I add them all together. Yeah.
Is there any other way to calculate area and have it exact, or is this something?
It would be closer if you use the summation. But these questions will ask you to approximate, and this approximation is what it's looking for. Like, there's only one answer to it when you do it this way, which is an approximation, but it is what they want. 376, 1.824, 2.144, 2.336, and you get 8.48. It didn't give me a unit, but if it did, it would be units squared. That's adding all of them up together. Welcome to calculus.
Uh-oh. She's gonna tell me it gets worse.
I mean, honestly, like, it's weird, yes, but the simple steps you know how to do, and once you practice it, it's not terrible. It's just tedious. Questions? All right, so this time we said there's 4, right? There's 4 rectangles. So the first one, first of all, our total length, again, this time was 2, right? But now there's only 4, so each of them is gonna have a width of what?
1/2.
1/2. This would be a half. The widths are all gonna be a half, but that would be 1. And then this would be 3/2 or 3
Oh, I
halves.
put 2/4, so I don't know.
That's fine. Doesn't matter. All right, so when I want to find my length, or my width is all 1/2, 1/2, 1/2, 1/2. My width here would be f of 1/2, or my length, sorry. My length here would be f of 1. My length here would be f of 3/2 or 1.5. You could plug in either one. And my length here would be f of 2. This time my formula is just plus 1. So I'd get 1/2 plus 1, and I could do 1/2 is my width, as my length could be 1 and 1/2. It could be 3/2. It could be 1.5, whatever it is. This would be 3/2 if I just multiplied it like that. Okay, again, you have your calculator, so if you wanted to turn that into 0.5 and 1.5, that's fine too, okay? This one would be 1/2 times f of 1 would be 1 plus 1, which is 2. So that's just 1. 1/2 times f of 3/2, 3/2 or 1.5 plus 1 is 2/2, or 2.5. So 0.5 times 2.5. And then 1/2, which could be 0.5, and then plug in 2. 2 plus 1 is 3. So when I add that, well, first we'll multiply it all out. This is 0.75, 1, 2.5, 1.25, and 1.5. And then add all 4 of those together.
We get 4.5?
4.5.
I stopped like halfway through.
Okay.
Or 1.
Yo, what'd you mess up?
I didn't add them.
Let's go.
Oh,
Good?
you had the 1?
No, like I didn't add them all together. I just
Oh,
put them in
I mean,
Oh. Oh, that's cool.
we good? Yes? Okay, we're stopping.